All right, problems 3 and 4 this time. Number 3 has y times x over x squared plus 3 as our differential. So for this one, what we want to do is see this for sure as y times x over x squared plus 3. So there's our y function and then our x function. What we're going to do is divide by that y while we bring the dx over, so that we get dy over y equals x over x squared plus 3 dx. Okay, now we're going to integrate both of these, and the integral of the left side will be pretty straightforward. We know that that's going to end up becoming natural log of y, the absolute value of y. So that part's not too bad. The right side provides a little bit of a challenge, and so we're going to have x over x squared plus 3. That's more than likely u sub, and when we've done these in the past, we've let that denominator be the u. So if you want to push this off to the side, we'll bring this over here, and we're doing integral of x over x squared plus 3 dx. We'll let u be x squared plus 3. So du is 2x dx, which means dx is du over 2x. Bring this back over here. We're going to have the integral of x over u times du over 2x. Our x's cancel like we like. We can bring that 1/2 out. And we've got integral 1/2 of the integral of 1 over u du, which is 1/2 natural log of u, plus c, which then makes 1/2 times the natural log of x squared plus 3 plus c. That's our right side. So we're going to bring that part back over here and have it equal this, plus c. All right, so we have separated the variables. We have integrated both sides. Now what we have to do is get y by itself. So to do that, we're going to raise both sides as a power of e to get rid of the natural log. So we have absolute value y equals e to the 1/2 natural log of x squared plus 3 plus c. Now this is technically correct, and if you were to just go ahead and get rid of this absolute value by putting a plus or minus in front of it, because technically absolute value could be the positive or negative version of this, you would technically be correct, but we want to go a little bit better than that. We want to try to see if we can make this look a little nicer. So one of the things the AP will do is the next, one of the two following things. What they'll do is they'll take this 1/2 right here, and they'll bring that up as an exponent inside the log. So you'll have e to the natural log of x squared plus 3 to the 1/2. That would be one of the things they do, just using a log rule, bringing the exponent in here. Sometimes they do that, sometimes they don't. The next thing they do is a little more common, and they'll see this plus c here, and they'll use a rule that kind of we're used to doing it the other way, but they'll do it this way. So you see that they've taken this e, which was a single base with this exponent, and they've split it into two bases, one with the one part of the exponent, one with the other. We're used to combining it the other way, taking two bases and adding the exponents to get to here. They're going backwards. Instead of adding the exponents to get to a single base, they split it like this. Now the reason they do that is because e is a number, to c a number will be, this will also be a number. This will be some constant. So they'll say that e to the little c equals big C, big constant. It's still a constant, but now that constant is multiplying this part. So instead of e to this complicated looking thing, they'll have this, which is a constant, times e to the natural log of x squared plus 3 to the 1/2, which really is the square root of x squared plus 3. Now, at that point, you should notice that we have e to the natural log, so that means we can cancel that, and we're actually going to get c to the times the square root of x squared plus 3. It actually simplifies all the way to something as simple as that. And then the last thing to do is since we have absolute value of y, let's just put it plus or minus. And that would be the simplest form of that. So again, technically, slapping a plus or minus in front of this would have worked, would have been just fine. But we can do a little bit of algebra, a little bit of mathy stuff to get all the way down to here, which is a little bit cleaner looking. Don't get too panicked if that seems, kind of tricky, but that's where we can go with that. All right. For number 4, this one's going to be a little more straightforward. We see we have the 1 plus y expression here. We got to take this whole thing together. We can't just take the y part separate. We got to take the 1 plus with it, but we can leave the 2 behind and the e to the x behind. So we're going to swing the dx over. We're going to bring the d1 plus y over. It's going to look like this: dy over 1 plus y equals 2 e to the x dx. Okay, we're ready to integrate. So I integrate on this side. We integrate on this side, okay? And the derivative, if this was just plain y, if it was dy over y, we'd do it just like we did the last one. This would become natural log of y. The derivative of 1 plus y is also dy. It's no different. So we're going to integrate this right into the natural log of not y, but 1 plus y. If you were to take the derivative of this, you would do 1 over 1 plus y times the derivative of that, which is dy. So it ends up working out pretty nicely. Over here, the integral of 2e to the x, 2 is just a constant, hangs out. The derivative of the integral of e to the x is just e to the x. So that's not too bad. Okay. Now what we got to do is get y by itself. So we're going to raise both sides to the power of e. That cancels here, gives us absolute value 1 plus y equals, and this is going to look really weird, e to the 2e to the x plus c. Okay. Now just like the last example, technically this is correct, but we could split that into e to the 2e to the x times e to the c, and then e to the c is constant, so we'll call that capital C. So this is going to give us big C times e to the 2e to the x equals the absolute value of 1 plus y. I'm going to get rid of that absolute value by just putting a plus or minus on this whole side here. All right, and then we just have to subtract 1. So it's going to be a minus 1 plus or minus c e to the 2e to the x. Looks weird, but that is correct. And that's all we got to do for that one.